Hi everyone, this is going to show you how we can process a CAD file into being a 3D printed file. Unfortunately, it's not quite as simple as literally going file print. I mean, you can set up CAD systems to do that, but with, say, Fusion 360, we have to convert this model into a 3D printable format. So the universal 3D printing format that we use for CAD files is called STL. To do that, in Fusion, we have to click on the body or the component that we want to 3D print, and we right-click and go Save as Mesh. Now, when it says Save as Mesh, we can see the format here says STL binary, and there's a few other like OBJ and stuff that are used, but basically STL binary is the main one that we use. You can change the resolution as well, and you can even preview what's called the mesh. So you can see here, this is how STLs work. They turn the parts into a series of very small, very thin triangles. The denser the mesh, if it's a high resolution, the larger the file is and the heavier it will run. So medium is usually fine, especially when we're doing FDM 3D printing. So I'm going to go OK on that, and I'm going to save that into my downloads folder. Just going to save that there. OK. The next thing I'm going to do is go to my CAM software. Note I'm saying CAM, Computer Aided Manufacture Software. We have moved away now from CAD. This piece of software here is now what we call a post-processor. This means that in softwares like this, you can't edit the model. You can't change anything on it. This purely is for preparing the model for 3D printing. So I'm going to open up the file. I'm going to go to my downloads folder there and go body STL. There we are. And open that up. So this brings the file in. You can see that the file here is lying down, and what happens with this software is it replicates the bed of the 3D printer that we have installed. So you can see this one here says Creality Ender 3 V2. So we could actually add a printer, and these softwares like this one, Creality Slicer, there's actually a lot of different 3D printers that are compatible with this software. So you could find that 3D printer, you could just install it into the software, and then the bed size will change, and also the print capabilities might change depending on the machine. So I've got the correct printer selected. Now, when you're 3D printing, you need to think about trying to minimize what we call support structure. Support structure is a nuisance. If you imagine this, a building, especially in Hong Kong, pretty much all buildings in Hong Kong are made of concrete. Concrete, when it's being formed, is liquid. And to be able to actually put a building up, you need to have scaffolding and formers in place to pour the concrete into. And then when it's set, it will solidify. 3D printing is the same, because plastic, when it's heated up, it's soft and it's sort of semi-liquid. It's quite viscous, but it's still a liquid until it solidifies. So if the 3D printer was trying to print this overhang here, what would happen is in the middle here, all it would do is it would just sag down and the whole thing would collapse on itself. So we have to give the model essentially it's bamboo scaffolding to make sure it stays up. So over on the left here, we've got various different things we can do. So if I was not going to change any of the orientation of this part here, what I would do is I'd need to apply support structure. So I'd select on here, just go to the simplified settings here. So I'd check support, and I can select like how high I want the resolution. So this is basically the print quality. These are in millimeters, these measurements. So if you want a really ultra high quality print, you can go down to 0.08 millimeters. Unfortunately, the higher the resolution, the slower the print time, because you've got to think that each layer of the 3D print is a slice which the print head has to move around. That, if it's really thin, that will take it ages. So you can see you can go right up to 1 millimeter. That would be an appalling print quality, but it would be a lot quicker. The infill is how much inside the wall sections it will fill in. Usually we keep this pretty low, unless you're doing a structural model where you might put it up to 100%. Okay, so I've just ticked supports, and we can close that now, and we can now go slice. And what will happen now is it's done it already actually. The software has now sliced the model into a series of layers to print. We can go preview. And this is actually what's more useful to see now. As you can see here, these are the very fine layers that the printer will move around. And we can see like how it's actually going to build up the model layer by layer. And inside here, you can see the support structure. And that's, as I say, literally our scaffolding. Now, this orientation of this model is very wasteful for printing, because all this support structure, we could actually just change the model's orientation, and then we could actually we could completely eliminate any need for support. Well, pretty much eliminate any need for support structure. So let's have another go at this. I'm going to delete that file there, and we'll just re-import it again. Okay, so I'm going to go new project, and we'll open this up again. So we'll just go open there. Okay. So what I can do now is instead, I can click on the model, go rotate, and I can rotate the model this way. And you can see it automatically lines itself up with the bed, and it puts itself in the center of the bed as well. You can move it around as well if you want. You can just drag on the arrows, but generally, I just always keep the models in the middle of the build plate. Now this way you can see the only overhangs we actually have now are these little diagonals here. The rest of that is all just vertical sides, so there actually wouldn't need to be any support structure. And we can test that by doing it again. I'm going to demonstrate to you what the 0.12 might look like. I'm going to check support anyway, just to show you that there wouldn't be any support needed really. And we'll close that and we'll go slice. So it's now going to slice the model into 0.12 millimeter layers instead. So you can see now the print time's gone up, 6 hours and 36 minutes. It gives you the amount of material that's used as well. It's 9 millimeters of filaments, and we can go preview again. Okay. So you can see here, we've actually now, the layers are much finer. They're much, much closer together. And so the result of that is the surface finish would be a lot better. You can see we've got a tiny bit of support in there just to support these areas here. But to be honest, there's no support really in that at all. That's a very efficient model build. Okay, the actual quality doesn't need to be that high. The reason being, guys, is you can actually just sand it down afterwards. There's not really any need to like print to that kind of level. So yeah, we can just leave it there. So then you go save to a USB stick, and then you put that onto the 3D printer and literally just press go. And that's how we prepare for FDM printing. Now, if we go to the other method, which is, well, this is actually for DLP and digital light processing, which is kind of the same as SLA. Let's try this and see how this is slightly different. So actually, you know what I might do? I might get a slightly more interesting model. Let's get this part here that, one of my year 13 students has sent to me. Okay, so we've got here a model that we're going to print. This, same as FDM, this would be the most efficient way of printing it, but I want to show you the difference in what the support structure looks like. So I'm just going to type in actually there so it's a bit more accurate. I'm going to type 90 in there, and you can see that's already aligned up to the base there. Now we've got lots of overhangs going on here. So I'm going to go DLP support now. You can see it's highlighted the areas which it says will need support. We can change some factors on the support as well. So let's have a look, see what this is going to look like. Now you can see with this type of printing, it looks very different. It's much more like a sort of lattice of, literally looks like scaffolding to hold up these layers. And you can, let's see what else, if we mess around with the settings, if I go reset, or actually, let's just go delete support. We'll delete that. Let's do it again. So if I change the support space, and we'll turn that right down like that, let's try again. So we go generate support. You can see it makes a much more densely packed support structure. So you can do this depending on basically how complex and intricate is your model. I mean, if we did it right up like that and go generate support, you can see we get very little. Now, the risk of that is that the whole model might start collapsing. So it's a bit of a dark art with this. You just have to sort of, go with the recommended. You can just go reset and go the recommended settings, and then that will give a safe model build. Okay, and when we've done that, you can then go print, and you can, same as this, we can just choose the resolution we want. DLP processing is generally much to a much higher resolution. We can go down to almost any resolution with this. And it will get to a very, very high quality layer of print. You can see there, this actually simulates what the print would do. And then we just go OK and export that. And that's basically it for the DLP processing. So everybody, that is it. That is how we post-process CAD.